Hello, today we'll be describing a relationship using calculus. So, first of all, in basically everything for calculus, let's start with the graph. So, here's my x and y coordinates, my Cartesian plane, and instead of the typical x and y, let's call the x-axis t and the y-axis h. So, is going to be one of our variables and stands for time, and h is going to stand for happiness or relationship level, how close you are. And yeah, this is going to be what we're going to be working with and how we're going to describe the relationship using calculus. So first of all, let's start with the first phase where you kind of don't know the other person. So your happiness or your relationship at this point is 0, right? So I'm going to draw like so. Actually, this color isn't really good. So I'm going to use this yellow color. So this is going to be stage 1, okay? It's going to be stage 1 where you don't know the other person, at least not well. Like maybe you're acquainted or something, but not well. Like not even acquainted, like you just don't know them. So in this situation, what can we say? Well, in this situation, what we can say, so I'm going to mark it here, is notice how we have the derivative of t, so let's call it h of t actually. So the derivative of h is equal to 0, which means that h is not increasing or decreasing in this situation. It's a constant part. It's a constant happiness level. So of course, this is a very easy start. Let's go to the part where you kind of start knowing each other. Maybe you start texting. So at this point, you'll see that, oh, your happiness, your relationship is increasing. And it seems to increase really fast. Maybe you start getting into the flirty phase, maybe you start flirting with each other. And what we can I say here? Well, those who know some calculus, you guys might see, oh, ht is greater than 0, right? And this means that your happiness is increasing because the slope is positive, and a positive slope means increasing. And not only this, notice how the slope it's increasing at a faster rate, right? So you're increasing slowly here, but as you get to know each other, you're kind of like getting into, you start having feelings for each other, your relationship increases exponentially. And then what that means is that the double derivative of h at this interval is also greater than 0, right? And this means that it's increasing at an increasing rate. That means that your happiness is increasing at an increasing rate. So if you want to take this in the physics point of view, it means you have an acceleration of relationship as well. So then you start to notice maybe something changed a little bit, and then you realize, oh, things are starting to slow down a little bit for you guys. So maybe at this point, you've already, started going out with each other, going on some dates. But sometimes after some point, it kind of just feels a bit off. Maybe you got into an argument. Or maybe something happened, right? Well, notice how here your happiness is still increasing. So maybe you are able to figure something out, right? Maybe something happened, but you're still figuring something out. But then maybe you're getting a bit tired. Notice how at the end your happiness is increasing very little, or even at the point where it's barely increasing at all. So how can we explain this with calculus? Well, first of all, we have h of t. The first derivative is still positive, because notice how although it's increasing at a slower rate, it's still increasing nevertheless. But since it's increasing at a slower rate, we can write the double derivative is less than 0, since it's slowing down. In physics terms, it's decelerating or experiencing negative acceleration, which means although it's increasing, it's slowly slowing down. Although it's still, like in general, it's still going upwards. So again, just to recap, we are increasing at a decreasing rate. So yes. This is essentially what it means. And there's also a term to describe this point right here, right? Where your double derivative is maximized and it turns from an increasing rate to a decreasing rate. Well, this point is called the inflection point. So an inflection point. And the inflection point is where h double derivative is equal to 0. Right? It's equal to 0. So you see how it's increasing here and it's greater than 0 here, it's less than 0 here. This point where it changes from increasing to decreasing, like positive to negative, This is the inflection point, and the inflection point signifies a maximum or minimum in the derivative. Well, most of the time, there are some exceptions to this, but usually this is the case. And in this case, it's the maximum. So in this case, maximum, because notice how as you go, sorry, the slope of the derivative increases all the way here. The slope is all the way to the top and then starts decreasing. So this point will be the maximum, the place where the derivative is maximized. So perchance this was maybe, this part. I don't. So for in a relationship, in our metaphor, this could probably be the time where you guys, had your first day. Maybe did some fun stuff. It was like a really good experience. When you guys start on the early days, but then let's move on. After this part though, something weird happens. You feel like you're getting a bit tired. You feel like your relationship is deteriorating. Oh no, it's going down, right? What's this in calculus? So maybe you guys went to a really big argument, Maybe, someone did some bad stuff, like just maybe cheated, maybe liked another girl's post too much, Something like that happened. So how can we explain this with calculus? Well, first of all, like the first parts, finally, the derivative is less than 0 because the slope is going down. Your happiness or relationship is decreasing, right? But what can we say about the double derivative? Well, notice how the double derivative, although it's accelerating downwards, the derivative is still decreasing, right? It's going to say this is like negative 0.1. It's going here like negative 4. So we can also say that the double derivative is less than 0 too. And this means your happiness is decreasing at an increasing rate. So don't let the double derivative less than 0 fool you. It's not decreasing at a decreasing rate. It's decreasing at an increasing rate. So although it might be a bit confusing, just think of it as your happiness is decreasing faster and faster and faster and faster. So this is essentially what this part means. And once again, you'll notice that the turning point here, this is good. Points like these are going to be called critical points. And in critical points, there's this special property here where, so I'm going to mark this with green. This is the critical point. And in this situation, the critical point is like a maximum or minimum. A critical point, so let me rephrase that. A critical point is where the derivative is 0 or undefined, and typically it denotes a place where the function reaches a maximum or minimum. There are cases, of course, where this isn't true. Say for this example here, there's a point in the middle where the derivative is 0, like the tangent line is 0, but this is clearly not a relative maximum or minimum, like not a clear no maximum or minimum along the interval near it. So yes, but in this case it is. Notice how if we drew a tangent line over here, it would be horizontal, thus having a derivative of 0, which means that in this case our derivative would be 0, and this would be a maximum. This shows the maximum happiness you have achieved throughout this entire relationship. So in this case we could have critical point / relative maxima. So we call this a relative maxima, or in this case an absolute maxima here too, because it's across the entire interval. And we call this and conversely there's also relative minima, signifying the lowest bound of the lowest value that on a certain graph. So in this case the minima would be on the two edges maybe, but in this case we have h of t equals 0, and it goes from h of t goes from positive to negative here. And this is really important because if it were from negative to positive, it would be a relative minima. So let me just quickly draw an example here. So say we had a negative slope and it had tangent line here, right? Tangent, and it went to a positive slope. That would be a minima. See, it's a minimum value, right? Hopefully that makes sense. But anyways, let's move on to the last stage. Last stage, you kind of already had an argument. You're kind of straying away from each other, right? And you're kind of going back to where you were before. So as you can see here, right, your relationship is still decreasing. So we can still write h of t is less than 0. But now it's decreasing at a slower rate. it's like not decreasing at an increasing rate like here. You're not like going worse and worse and worse much faster. You're going slower. And in this case, we have h of t is greater than 0. And we have decreasing at a decreasing rate. And yes. And notice how we have another inflection point here. Remember inflection points here? Well, it's the exact same thing here. So I'm going to copy this and paste it over here, right? It's the exact same case. This is where the double derivative is 0, but instead of being the maximum derivative here, this is the minimum derivative. Yep, because it's going from a really steep negative slope to, and then it's starting to ease into a less steep negative slope. So there you have it. This is describing a relationship that obviously failed using calculus. And yep, this is all I have. Hopefully you learned something from this video, and yeah, have fun with math. And if you're taking AP Calculus and watching this video, good luck. On the test, it's in a month. You guys got this. Thank you for watching.